Let's go over the question together. What is the osmotic pressure in atmosphere of a solution of a protein with a molar mass of 5.87 times 10 to the power 3 grams per mole at 26 degrees Celsius if 100 ml of the solution contains 0.14 grams of the protein? Next, let's summarize the information given and find out what we need to find. So first of all, we need to find the osmotic pressure of this solution. We know that 100 ml of the solution contains 0.14 grams of a protein with a molar mass of 5.87 times 10 to the power 3 grams per mole. And we also know that the temperature is 26 degrees Celsius. So first of all, we look at the formula to find osmotic pressure of a protein, of a solution. So that formula is going to be pi equals I times m times r times t. So pi, first of all, stands for osmotic pressure in atmosphere. I is the Van Hoff factor. M is the molarity of the solution in moles per liter. And R is a gas constant, and here we use the value of 0.08206. Finally, T stands for temperature in Kelvin. And so first, let's talk a bit about what is the Van Hoff factor. Van Hoff factor is the number of particles in solutions per formula unit. So for example, for sodium chloride, its Van Hoff factor is going to be 2 because NaCl in a solution will dissociate into Na plus Cl minus. That's 2 ions. And so the number of particles in solution is 2 per 1 formula unit of sodium chloride. Another example would be for sucrose. The Van Hoff factor will be 1 because unlike sodium chloride, sucrose does not dissociate into multiple particles. So it's just going to be 1 particle in solution per 1 formula unit of sucrose. And so now back to our problem. To solve for osmotic pressure, we'll need to find I, M, and T to plug into the formula. So first of all, for Van Hoff factor, for the protein, the Van Hoff factor is going to be 1 because protein does not dissociate. Therefore, there will be just 1 particle in solution per 1 formula unit of protein. Next, we need to calculate the molarity of the solution, and the formula for that would be moles of protein divided by liters of solution. First of all, we'll need to find the moles of protein, and the formula for that is going to be mass of protein divided by molar mass of the protein. Both of these numbers are given to us in the prompt. So that's going to be 0.14 grams divided by 5.87 times 10 to the power 3 grams per mole. And it's going to give us a value of 2.385 times 10 to negative 5 moles. Next, we need to find the liters of solution. It is mentioned that there is 100 ml of the solution. Now all we need to do is to convert that to liters. So take 100 ml times 1 liters over 1000 ml to convert it to 0.1 liters. Now with all the number, let's just plug in to find molarity. That's going to be 2.385 times 10 to negative 5 divided by 0.1 liters. And together, that's going to be 2.385 times 10 to negative 4 moles per liter. And next, the last thing we need to find is temperature. So it's given to us that the temperature is 26 degrees Celsius, but we do need to convert that to Kelvin. So 26 degrees Celsius plus 273 to give 299 Kelvin. Now with all the information gathered, let's just find the osmotic pressure by plugging the numbers into the formula. So again, the osmotic pressure will be equal to I times M times R times T. That's going to be 1 times 2.385 times 10 to negative 4 times 0.08206 times 299. And that's going to give us a value of 5.85 times 10 to negative 3 atmosphere. And this is the osmotic pressure of the solution. Thank you for watching.